to prove this statement is true for all positive integer n. So step number 1, we need to prove n equal 1 first. And step number 2, we assume that it is true for n equal k. And then we need to prove it is true for n equal k plus 1. And then we need to write the last statement, okay? So let's get into it. So proof for n equal 1. So on the left hand side, when n equal 1, the answer is 1 over 1 times 3. And on the right hand side, we replace n with 1 because n equal 1. So that is 1 over 1 times 3 is equal to, on the right hand side, which is 1, 2 times 1 plus 1. So which is 1 over 3, and 2 times 1 is 2, add 1 is 3. So the answer is 1 over 3. So it is true for n equal 1. So just write this down. So therefore, there you go. Now we assume that it is true for n equal k. So this means that we need to replace n with k. Now we need to prove for n equal k plus 1. So this means that on the left hand side, we need to write all the ways to k plus 1. So that is 1 over 1 times 3 plus 1 over 3 times 5. So this is up to k terms, but we need to write all the way to k plus 1 terms. So we need to write 1 term extra. That is when n equal k plus 1. So we add and 2 k plus 1 add 1. So I just prove for left hand side first, and then I prove right hand side. So they should be equal. So I just write, this is left hand side. And please note, these terms here is equal to k over 2k plus 1. So I just write this down. So which is equal k 2k plus 1 plus the last term, that is and 2k plus 1 plus 1. So what I do now is I just simplify these two terms. So I just write this first term out first. Add. So I just expand this out, give me 2k plus 2 and minus 1. So that give me 2k plus 1. And then we have 2k and plus 2 and add another 1. So it becomes 2k plus 3. Then I just add fractions. So the common denominator for this is 2k plus 1 and 2k plus 3. So in another word, I times this by 2k plus 3. And the bottom is times by 2k plus 3. So I'm going to write this in one fraction. So that equal to k 2k plus 3 and we add 1 over 2k plus 1 and then 2k plus 3. So now I just expand the top and then I factorize, okay? So I just write equal to 2k squared plus 3k plus 1. So now I just need to factorize the numerator. So 2k squared plus 3k plus 1. So 2 times 1 is 2. I just write this out because these are positive. We just copy that out. So 2k plus 2k plus and everything divided by 2. So two numbers times together to give me 2 and then we add to give me 3 here. So that is 2 and 1. So I just put 2 and 1 here. Now, if you need to practice more on these factorizing skills, so please go to the description below and then click on the link. So let's get into this now. So what I do, I take the common factor out, which is 2, and this is 1. And these 2 cancel out. So which is k plus 1 and then 2k plus 1. So that is equal to k plus 1, 2k plus 1. And the bottom here is 2k plus 1 and 2k plus 3. Then I can simplify by 2k plus 1 here and 2k plus 1. I can cancel it out. So the answer is equal to k plus 1, 2k plus 3. So therefore, left hand side is equal to this. Now what we need to do is we need to prove right hand side. So right hand side, so we need to replace n with k plus 1. So let me write down here. So now on right hand side, which equal to, so I just substitute k plus 1 into this expression here. So that equal to k plus 1 and 2 k plus 1 plus 1. So that will give me k plus 1 and 2k plus 2 plus 1. So which is equal to k plus 1, 2k plus 2 plus 1 is 3. So therefore, the left hand side is this and the right hand side is this. So we can write therefore, left hand side is equal to the right hand side. So now we can just write the statement for this. So therefore, it is true for n equal k plus 1. Now we just need to write the last statement. So that we write therefore, the statement is true for all positive integer n by mathematical induction. So there you go. Now please pause the video and try this one yourself. Hi, I'm back. Let's go through it, okay? So step number 1, we prove for the smallest n, which is n equal to 1. So on the left hand side, we get this. And on the right hand side, we just need to replace n with 1. So which is 1 times 5 is equal to 1 over 6 times 1. And then 1 plus 1 is 2. And then 2 times 1 is 2. At 13 is 15. Then that's left hand side equal 5. And this 6 I can cancel. That give me 3. Cancel this, give me 5. So 1 times 5 is 5. So therefore, it is true for n equal 1. So let me write this down. So now, we assume that it is true for n equal k. So we replace n with k. Now, we need to prove for n equal k plus 1. So on the left hand side, we need to write all the way to k plus 1 term. So that is left hand side is equal to plus and this is up to k terms, but we need to write 1 term extra because we write all the way to k plus 1. So we replace n with k plus 1. So the last term is k plus 1 and then k plus 1 at 4. So now we just need to simplify. But then because of these terms here, as is equal to this. And then we add the last term, that is k plus 1. And I simplify, so that is k plus 1 plus 4 is 5. Okay, so plus 5. So now what I do is just write in one fraction form, okay? So therefore, the common denominator for this is 6. Because this is 6 here, so I just put this is 6. And I times this by 6. So I just write in one fraction first. There you go. So now I take out the common factor. So the common factor is k plus 1 and k plus 1 there, right? So I just take it out. K plus 1. And then inside, leave with k. And then 2k plus 13. And add 6. And then k plus 5. Over 6. And of course, this is another bracket. Now, inside the bracket, I just expand and I simplify, okay? So that will give me, I write k plus 1 first. And then this one here, I times 2k times k is 2k squared. And k times 13 is 13k. And then we remove bracket for this one. So give me 6k. And then this time together, plus 30. Over 6, of course. Then I simplified further and then I factorize, okay? So I write this first. K plus 1. And then 2k squared. And 13 plus 6, which is 19. So add 19k and then add 30 over 6. But then I can just write 1/6. Okay, it's the same. So what I do now, so I just factorize this. Okay, so let me just write out here. So 2k squared plus 19k plus 30. And 2 times 30 is 60. So two numbers times together to give me 60 and add to give me 19. So 60 is 10 and 6, but add together give me 16, right? So therefore it should be 4 and 15. So it's 60 as well. And then add together give me 19. So I just write 2k plus and 2k plus first. And of course divide by 2. And then 4 and 15. So it doesn't matter where you put. So for 15 here. Now the common factor for this inside here is 2. So that give me 2 here. That 2 cancel out. So I should get k plus 2 and 2k plus 15. So now I just write it out on here. So which is equal to 1 over 6 k plus 1, k plus 2, and 2k plus 15. So that is the left hand side. So therefore, left hand side is equal to this. Now we need to prove right hand side. So for right hand side, which is equal to, remember, n equal k plus 1. So this is the right hand side here. So we need to replace n with k plus 1. So that is right hand side is equal to 1 over 6. So 1/6 and k plus 1. Because n is replaced with k plus 1. Don't forget, okay? So k plus 1 add 1. And 2 k plus 1 add 13. So now what I do is just simplify further. That's all. So that give me 1 over 6 k plus 1, k plus 2, and then I times this out, give me 2k, and then 2 times 1 is 2, at 13 is 15. So therefore, right hand side is equal to this. So let's see. So we have left hand side is this, and right hand side is the same. There you go. So that means it is true for n equal k plus 1. So therefore, we need to write the conclusion for this. Therefore, the statement is true for all n greater or equal to 1 by mathematical induction. Thank you so much for watching. Bye.